Welcome to AS Level Organic Chemistry Series Part 1. Now in this, we'll start by discussing different types of formulas you may have for your organic chemistry compounds. Okay, you might already be familiar with some of them from your studies in IGCSE organic chemistry, right? So we'll start with empirical formula. Now empirical formula basically gives us the simplest ratio of the atoms present in the compound. For example, a substance may have multiple atoms present in it, right? But the basic ratio is represented in this one, in the empirical formula. Now, what about the molecular formula? Molecular formula gives you the actual number of atoms present in your molecule. If you want to find the molecular formula from your empirical formula, you basically need two things. First of all, you need to know the relative molecular mass of the molecule. Okay, so let's say of the molecular mass of this of the actual molecule is 42. All right, and then you need to divide this number by the relative molecular mass of your empirical formula. C is 12 and hydrogen is 1, so this is plus 2. Okay, because you have two hydrogen, that's why it's 2. This will give you 14. So 42 divided by 14 equals to 3. You're just going to multiply this by 3, CH2 times 3, and this will give you C3H6. This is basically an alkene and it has 3 carbons, 6. That's your molecular formula. Then we'll talk about displayed formula now, okay? So displayed formula, basically in this formula, all the bonds within the molecule are shown. You can see them. So this is how it's going to be. So you have propene, right? You have 3 carbons, 1, 2, 3, and then you have a double bond. It could either be here, the first carbon, or the second carbon, does not matter. And then you have your hydrogen over there. We'll actually keep this one, arrange it like this. This is the third carbon, one, and then it has 3 more hydrogen. This is for AS chemistry, this is how you're supposed to be arranging your atoms. Now a displayed formula, this can also be represented in a 3D way. Okay, this was 2D because this represents you the formula in one plane. Now in 3D, we have to show whether some are sticking out of the paper or into the paper. Okay, so let's say I have methane, so you'll have C here, and then 4 hydrogens are equally apart from each other. So I will say 1 hydrogen up, and then I have 1 hydrogen which is sticking out towards me, out of the paper. So I will write this as H, and then the other ones are behind the paper. Okay, well, we'll keep 1 hydrogen on the paper because that's how it's represented in the books. And that's the 3D displayed formula. Now a simpler version of this displayed formula is skeletal formula. So let's write down the skeletal formula for propene. Basically, you're just supposed to draw the lines. Now here you have 3 carbon atoms, right? So this is carbon 1. This is how you will do it. This represents first carbon, second carbon, and third carbon. Okay, like a line like this. So, and then you have a double bond between the first and second carbon, so you'll draw another line here. Now in this formula, any carbon and hydrogen atoms are not displayed. But for example, if you had over here, if you had an alcohol, an OH group, you would show this like this, OH. Moving on to structural formula. Structural formula just shows you basically shows the structure. It tells you which bonds which carbon are attached to which one. So let's write the structural formula for this compound. So you have H2C, which is represented from this region, and then you have double bond CH, and then you have CH3 OH. Okay, now notice it does not mean that hydrogen is bonded to oxygen. Okay, it's showing you the structure. Oxygen is connected to a carbon here. Now in this part, we're going to discuss how to name organic compounds. This is also discussed in my previous IGCSE organic chemistry videos, so you can look into that. And this might be very easy for you if the basics are right for you, okay? But we'll go through it here as well. Now, whenever you want to name, you have to look at the main chain, okay? This is the main chain, and you have one branch or one side chain. You're going to start numbering from where you have the side chain, okay? So this is going to be carbon 1, carbon 2, carbon 3. You're not going to name it from this side 1, 2, 3. Now, if in case if this CH3 was over here, you will number from here. Okay, you have to start numbering. That in the end, that produces the lowest numbers. Okay, so let's start numbering. This is going to be 1, 2, 3, 4, 5. Okay, so this is pentane. This is pentane because this is an alkane with 5 carbons. Now, in a side chain, you have a methyl group, CH3, and this is attached to the second carbon, right? So you will call this as 2-methyl. Okay, now we have another example. Can you try to do this on your own first? If you are done, let's start naming this. Okay, so you have this main chain, right? Where are you going to start counting? You're going to start counting from here, 1, 2, 3, because this will give you a smaller number in the name. If you start counting from here, 1, 2, 3, 4, you're getting a bigger number, so that's not correct. Okay, so let's number it. 1 carbon, 2, 3, 4, 5, 6. Now you have 6 carbons, so you will call this as hexane. And then on the third carbon, you have a methyl group. So this is known as 3-methyl hexane. Okay, notice that this is the functional group. Okay, now let's move on to another example. Now you have multiple side chains. Okay, so how are you going to name this? First of all, let's just name the main chain. Starting from here, 1, 2, 3, 4, 5. So this is a pentane. For 5 carbon, you have pentane. pentane. Okay, so when you want to name this, you can notice you have you have 3 methyl groups, right? You will call this as trimethyl pentane. And now, where are these 3 methyl groups attached? 2 of them are attached to the second carbon, and 1 of them is attached to the third carbon. So you will name this as 2, 2, 3 trimethyl pentane. Okay, can you name this one? If you are done, let's start naming it. This is going to be carbon 1, 2, 3, 4, 5 carbons. So again, you have a pentane. But now you don't have 2-methyl. First, you have a methyl group, and then you have an ethyl group. Why? Because you have 2 carbons here. So let's start naming this. This is going to be 3-ethyl because your ethyl group is attached to the third carbon, and then you have 2-methyl. 3-ethyl 2-methyl pentane. That's the name. Now we have another example. Can you name? We'll have to name the organic compound from a skeletal formula. Okay. Remember, in the skeletal formula, each of these points are representing 1 carbon. Okay. So let's name this. You have C, 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 and then these are attached to other carbons. Okay, and this is a C as well. Now, what is the main chain? This is basically your main chain. So you will count how many carbons you have. This is carbon 1, carbon 2, 3, 4, 5, and 6. Okay, so in the main chain you have 6 carbons. So you will call this as hexene. Why hexene? Because you have a double bond. So this is not an alkane, this is an alkene. You have a functional group of alkene, of double bond, right? Now you have, because you have a double bond, this is your functional group. Now the double bond is on the second carbon, so you'll call this as hex-2-ene. Let's name this hex-2-ene. The double bond is on the second carbon. And then what about your, so you have a carbon here and over here, and then 2 carbons here. Let's see, what are these? These are basically attached to 3 more hydrogens, and this is just a methyl group because you have just 1 carbon, right? So you basically have 3 methyl groups. Therefore, we will call this as trimethyl. And then on which number of carbon are these methyl groups attached to? 1 of them is attached to the second carbon, and 2 of them are attached to the 5th carbon. So we will call this as 2, 5, 5 trimethyl hex-2-ene. This may sound very complicated, but when you get the hang of it, it's going to be very easy. Can you try to name this now? Remember the nth, this represents a carboxylic acid group. Okay, so if you're done, this is your main chain. How many carbons do you have? 1, 2, 3, 4. Okay, do not count this as a carbon because this is for the OH. Okay, so the main chain has 4 carbons and this is butanoic acid. And then you have methyl groups, 1 carbon here, 1 carbon here. Both of them, one of them is on the second carbon and the other one is on the third carbon. So you will call this as 2,3 dimethyl butanoic acid.